Welcome to Lesson 4 of our Hibernate series. Today we're focusing on two core concepts in Hibernate transaction management and caching. These are critical for ensuring data consistency and improving performance in database operations. By the end of this lesson, you'll understand how to manage transactions effectively and leverage caching for optimized database interactions. Let's dive in. First, let's talk about transactions. A transaction is a series of database operations that must be completed as a unit for data integrity. In Hibernate, transaction management ensures that data remains consistent, even in complex workflows. To manage transactions in Hibernate, you can use methods like, and here's a quick example. Begin transaction starts a transaction. Commit saves changes to the database. Rollback undoes changes if there's an issue, keeping the database consistent. Additionally, Hibernate supports different propagation and isolation levels, which control how transactions behave, especially in concurrent environments. When working with transactions, error handling is essential. Using blocks around transactions allows you to manage exceptions and roll back transactions if a failure occurs. For instance, if an error is caught, calling ensures that partial changes don't persist in the database, preventing potential data corruption. Caching in Hibernate. Now let's look at caching, a powerful feature in Hibernate that helps enhance application performance by reducing redundant database queries. Hibernate has two levels of caching: first-level cache and second-level cache. First, the first-level cache. This cache is built into the Hibernate and automatically caches entities within a session's lifespan. It clears whenever the session closes or flushes, meaning it doesn't persist data across multiple sessions. Next, the second-level cache. The second-level cache operates at the level and can persist cached data across sessions. This cache is optional and relies on external cache providers like Akash or Hazelcast to function. By using this, you can avoid repeated database hits, especially for data that doesn't change frequently. Implementing cache in Hibernate. To enable the second-level cache, you'll need to configure it in Hibernate settings and choose a cache provider. Once set up, Hibernate will automatically manage this cache for improved query performance. For example, after configuring Akash as the provider, any subsequent queries for cached entities will pull from the cache rather than the database, significantly boosting performance. Practical exercise. Here's a practical exercise to reinforce today's concepts. First, enable and test Hibernate's first-level and second-level caches. Experiment by loading entities within and across sessions to see how the cache works. Then, simulate transaction operations by introducing rollbacks to see how transactions ensure consistency, even during failures. Conclusion. And that's a wrap on transaction management and caching in Hibernate. By mastering these tools, you'll ensure both data integrity and performance in your applications. Join us next time for more advanced Hibernate techniques. Until then, happy coding!